Talk of its return is already making headlines, and predictions about the upcoming Atlantic hurricane season are already taking it into account. So it's time we had another talk about El Nino. Now, to understand its roots, we head to the tropical Pacific Ocean, where the dominant winds within about 25 degrees of the equator are the trade winds, which blow from a general easterly direction. These persistent winds push the warmest surface waters toward the western Pacific. So the normal or neutral state of the equatorial Pacific has the warmest waters in the west and somewhat cooler water in the central and eastern part of the ocean. Now, during El Nino, the trade winds weaken, and as a result, some of that relatively warm water slowly leaks back eastward, so that you eventually end up with warmer than average water in the central and eastern equatorial Pacific and cooler than average water in the western Pacific. Now, this year, the slosh of warmer water eastward got a boost from an unusual source earlier this month. 2 tropical storms in the western Pacific, one on either side of the equator. That's Sinlacao to the north with its counterclockwise circulation, while tropical cyclone Mila lies south of the equator, where the circulation around storms is clockwise. Notice that between them, the combination of opposite spins produces a westerly wind. And this so-called westerly wind burst helped with the push of warmer water toward the east in the equatorial Pacific. And you can actually see how that made a difference. Here's water temperatures in the top 1,000 feet or so of the ocean compared to average near the equator in the Pacific back in mid-February. The western Pacific is on the left, eastern Pacific on the right. The reds indicate warmer than average water, and even in mid-February, there were signs that warmer water was creeping eastward, mainly below the surface. Now here's mid-April. The warmer than average waters were more widespread, closer to the surface, and warmer. And this warmth is rising toward the surface, on target with forecasts of a strong El Nino developing this summer. So why does that matter here? Well, for starters, El Nino alters the jet stream, particularly the subtropical jet stream, which most directly affects the southern United States. When those waters warm in the central and eastern Pacific, the air above also warms, and that increases the temperature difference between the tropics and the mid-latitudes. And that speeds up the subtropical jet, which then tends to increase moisture and storminess along the southern United States, particularly in fall and winter. And that stronger jet stream also extends into the Atlantic, making it harder for storms to form there because speedy, high-altitude winds are poison for fledgling hurricanes. That's the key reason that early projections for this coming Atlantic hurricane season call for a below-average number of storms. I am certain that we'll have more on El Nino in coming months. Stay tuned. We'll be back in a moment.